Welcome back, everyone. 3 more fantastic talks for the rest of today. I've already introduced myself many times. I'm Mary Schenk. I'm the director of the Life Sciences and Society program that's running this symposium. But I'm also co-chair of the organizing committee for Saturday Morning Science. Many of you know that this is the time and place that Saturday Morning Science is held almost every week during the academic semesters at MU. So even when we don't have a big symposium coming on, we have a lot of people coming in here and hearing great talks about sciences and social sciences every week. And I invite you to look online, Saturday Morning Science at University of Missouri. You'll find the website with the rest of our talks for the rest of the semester. And if you ask us, we'll put you on our mailing list and we'll let you know when we've got talks lined up for next fall. We actually are going to have a special talk this summer, right at the end of July, a joint with the animal behavior meetings, which are being held at the University of Missouri this year. So there'll be one special midsummer Saturday Morning Science talk as well. So this is a joint venture of both groups here at the University of Missouri, and a lot of what we do here is supported obviously by the university itself. So we've invited Provost Garnet Stokes to come invite today's speaker.
Thank you, Mary. Good morning, everyone. It's great to see such a wonderful crowd, and I am delighted to be here to introduce our speaker for this Life Science and Society Symposium. I mean, this is a great thing for integrating the university and the community, but it's also a great thing for showcasing Mizzou nationwide. And I am even happier to be able to present our speaker this morning, Dr. Marshall Shepard. He is the Georgia Athletic Association Professor of Geography and Director of the Atmospheric Sciences Program at the University of Georgia. Now, it turns out he's been interested in meteorology since he was 6 years old. And I found that out because yesterday I was meeting with him, and his daughter, who's 12, had already decided the very specific thing that she intends to do when she grows up. And I said, now, did you have that kind of insight at 12? And he said, well, actually, when I was 6, I decided to be a meteorologist. And I thought, that's pretty remarkable. So he did all of his degrees at Florida State University, which has a really exceptional meteorology program. And after that, he worked at NASA for, I think it was about 12 years. He's an expert in areas of weather, climate, and atmospheric sciences, and he specifically studies those as they relate to urban areas. In fact, he's working on a book called The Urban Climate System. And having lived in Georgia, I used to hear some of his expertise related to Atlanta. He is a former president of the American Meteorological Society, a member of the AAAS What We Know panel on climate and climate change. His work has been funded by NASA, the Department of Energy, the Forest Service, the National Science Foundation. He's brought a whole lot of money to the University of Georgia. He has testified before Congress, has appeared on several news programs, including the Today Show, Larry King Live, Face the Nation, and he's actually the host of a show that I hope you've seen called Weather Geeks. It's great. I mean, it's really fabulous, and I think it's made a big difference in our understanding of a whole host of things. He did a great TEDx Atlanta talk called Slaying the Zombies of Climate Science. And in 2014, he won the Captain Planet Award. You know, I was Dean of Arts and Sciences at the University of Georgia when I had the opportunity to hire Marshall Shepard. And I can tell you, he's one of the greatest hires I made as a dean. And I discovered that he was also looking at a job in Michigan. I was very happy to find out that his wife ruled that out because it was too cold. When I was at Florida State as provost, I was going, as he's a triple alum, he's got an alumni awards, I was going to hire him there. But then I came to Mizzou, and I thought, well, maybe I can hire him at Mizzou, but I'm afraid his wife is going to think it's too cold. But not this winter. Anyway, I couldn't be happier to introduce our speaker today, Marshall Shepard.
If this is on, can you hear me? Okay, great. Let's go ahead and make sure I always like to get my technology, make sure that's working. It's really an honor to be here, and it's even more of an honor to have Provost Stokes to introduce me. I'm just going to be very candid because I'm a candid kind of guy. When I saw the lineup of speakers here, I was like, wow, it was really an honor to be invited here. But one of the primary reasons I said yes is because she was here, and I wanted to have a chance to at least see her again. It's always, we don't see each other as often. It's always good. She's a good friend and colleague. So, that was really a strong suit of me saying yes to the agreement, in addition to such a great symposia that you have here. So, I know it. It's not that I'm psychic, but I know when you saw this title, you probably were like, where is he going with that? So, and I promise you that I will tell you over the course of this next 40 or so minutes where I'm going with this title, Zombies, Cola, and Sports, Implications for Communicating Weather and Climate. As you've heard, over the course of my career at NASA and at the University of Georgia as president of the American Meteorological Society, I actually get called into the fire, so to speak, in terms of speaking on climate change, briefing the Senate. In fact, just last week we were up at the White House and Congress rolling out a new National Academies report on extreme weather linkages to climate. And I'll say a little bit about that later on in this talk. But I also talk to Rotary clubs and the media, and some of the things that I've picked up over the years as it relates to both communicating weather and climate from a scholarly perspective and just from an experience perspective, I like to share in these types of venues. So thank you for coming out. If you are on Twitter, feel free to follow me at Dr. Shepard 2013. The show that I host on the Weather Channel, Weather Geeks, that you heard about, comes on every Sunday at noon Eastern, so 11 o'clock Central, your time. Actually, tomorrow's show will feature Admiral David Titley, the chair of the National Academies Committee that did the report on extreme weather. So I invite you to check that out. It's going to be a quite interesting show, to say the least. And it's going to be a headache for me on Twitter afterwards, but I'll deal with that later. So let's just kind of jump right into it. This is, on the left, you don't have to worry about the details, a survey of the opinion between the public and scientists on various science topics. This was issued last year or so. And the real point I want to make here is if you look at topics like climate change and some of the other sort of topics of the day in science, there's a gap between what experts, scientists, say about that topic versus what the public says about that topic. How did we get there? I mean, that's a fascinating question. How did we get there to the point where 87% of scientists say that climate change has a human signature, but only 50% of the public? Well, there's some reasons, and we'll kind of walk through some of those today. And I'm sure Naomi Oreskes, who is another reason I was actually thrilled to come here. I know a lot of the speakers, but I'd never met Naomi, and she's, as you all know, one of the top voices in our field, and so it was an honor to have a chance to meet her as well. So the point is, how did we get here on climate? It's not by accident, and I think many of us understand that. And so the role that I play as a scientist is to try to increase climate science literacy on these topics and also publish the best science that I can. I'm actually a publishing, practicing scientist. And that's important because although I'm giving you a communications talk today, I publish in the peer-reviewed literature. I'm a fellow of the American Meteorological Society. So I've got the cred, if you want to check the record. I've got the cred. So that is, and that's important because there's a lot of folks speaking on this topic or just speaking on it. So that's these are my coordinates. Distinguished Georgia Athletic Association professor. I don't do anything related to athletic research. Let me say that right off the bat because sometimes people see that in my title. I was like, I thought you were a meteorologist. What is that? Are you doing kinesiology now? But it's interesting. The University of Georgia's Athletic Association kicks over money back to the President Jerry Moorhead, and they have a competitive endowed professorship program, and I happen to be one of the first to receive one of those in my particular area. So we have an atmospheric sciences program, and those are also my coordinates. And I do write a column periodically for Forbes magazine, their online presence on weather and climate. So I've got a few sort of places that you can keep up with me if you're interested in some of the things that I'm saying today or otherwise. And it's important, this is something from a magazine interview recently, and people say, well, aren't you worried about being considered a popularizer or you're sort of science light because you're willing to talk to the media or the public and whatnot? And I said, as I mentioned, I've done the things sort of to check off the academic boxes. I'm pretty good there. I'm pretty safe there. But we've got to get out of the ivory tower, particularly on this topic. Because if we're not out of the ivory tower, if climate scientists and professors who have expertise in this topic are not out there speaking accurate scientific information, then those that are skilled in communications, but not necessarily climate, will happily fill the void. So it's important that we are there. And so that's why I do things like the television show, Forbes. Only reason I put this up, full disclosure, it's just cool to have a selfie with Bill Nye, the science guy. But I also just know that he was a speaker here in this symposium recently, 2 years ago. So this is at the White House actually last year. The guy next to me is Charlie Bolden, the head of NASA. And then you've got Congressman Bill Foster from Illinois, actually one of the, I think the only physicist in Congress, and one of their staffers. So I get outside of the ivory tower, and just I know that there are some grad students and others here in the audience today and some younger folks. Important note of caution. If you do at some point in your career, and don't do it too early, make sure you establish your scientific credentials first, which is what one of my mentors, Dr. Warren Washington, said to me. But once you're willing and able to foray into the public space on controversial topics, you've got to have the unshakable temperament that is necessary for times when you may be challenged. Because trust me, on climate change, there are a host of opinions and viewpoints. And some folks will let you know about it. And so you have to be very aware of that. You can't get upset. You can't take things personal. I actually am very amenable and I get along well with some that people would consider climate skeptics out there. I'm very collegial with those folks. I've been in their homes. And so, we can disagree and still go out and have a glass of wine or a beer. So today my goals are very simple. I want to discuss 6 challenges in communicating weather and climate from my lens as a scientist and someone that's in the public sphere. So that's what we're going to do today. And the first challenge is that everyone has a bully pulpit. I've seen this just today and again leading up to this event. And in weather and climate, this is what I face. This is what I deal with. Who's the expert in weather and climate? There are a lot of people that think the Farmer's Almanac is as accurate as a weather predictor, but it's only 37% accurate. It has very general statements based on climatology that it's going to be hot in Atlanta in July. So those are statements that are sort of climatologically based, but in terms of specific deterministic weather forecasts, it's not very accurate at all. I've actually written an article in Forbes on that. The groundhog, it's a rodent. It doesn't understand the quasi-geostrophic equation and all. But, it's really for fun. My point here is on weather and climate more than ever, there are a host of people, because they simply have access to the public through social media, blogs, and otherwise, that are perceived or portrayed as experts. So here's a picture of John Knox and myself. This is on the set of the show. This was actually an episode we did on aviation weather, and John's a colleague of mine at the University of Georgia. We're scientists. A lot of people consider their local TV meteorologists to be the expert on weather and climate. And there's some interesting sort of discourse about that as well that I'll share later. Even your knee on a rainy day, oh, my knee's hurting a little bit, There's actually some value. There's actually, the atmospheric pressure, barometric pressure, your joints are somewhat sensitive to that. So there is some truth in that, right? So, and something else I think we coined on the Weather Geeks show, the rise of the social meteorologist. So every year, right before the winter starts, this gets around. So there's going to be and see, the problem with that is my cousin in Canton, Georgia, that comes across her Facebook feed. She doesn't know whether that's legit or not. And so it gets forwarded and reshared and retweeted. And so now we have this viral, it's going to be a snowstorm 3 weeks out. We don't even have the skill to say that in meteorology right now. So these are the types of things that we're dealing with. On the climate scale, this is just one example of what I call zombie theories, which I'll talk about later in the talk. Dr. Shepard, it's the sun. That's why we see this sort of trajectory in warming. I worked at NASA for 12 years developing advanced weather and climate satellite systems. And NASA has various satellites up monitoring solar activity. We have other types of measurements. And the solar cycle, the sunspot activity, the solar activity, those things just don't match up with the climate, the temperature record that we've seen over the last 30 to 40 years. But that's a favorite that I hear often, among many others that I'll talk about later. So this notion of the bully pulpit is important. The second challenge, and I'm going to kind of come down the street of my fellow academic colleagues here a little bit, too many graphs, too much jargon, and not enough common ground. I find this to be a challenge as well, particularly when communicating in public space. Now, I look at that and that just is so meaningful to me. I know exactly what I'm looking at. It's clear. It's scary because if you look at this is the temperature record for February from 1880 up to the present. Look at that large spike there in 2016. I know a lot of climate scientists, and when we saw this, we were like, whoa. I mean, the fact that of course we're in an El Nino, that certainly is driving some of it, but when we saw this spike, we were like, whoa. My point is, this is a graph we love as scientists to show, right? My wife looks at this, okay, it's just, I mean, she's a college educated, master's degree, but there are things that just aren't as intuitive in this as they are to me. Even though we think that it is. We show this, we throw this up comfortably. She said, well, why is it oscillate? I mean, there's still questions that, a congressman may have about this, right? Another example. I show this to my wife, she said, I just see a bunch of lines. But to me, I see the fact that last winter in Boston, they had one of their snowiest, if not their snowiest winter on record, and they got there relatively quickly compared to average. That was very intuitive to me. But my wife just sees a bunch of colorful lines when I throw this up to her. So as scientists and as scholars, we have to be very aware of our messaging, the old sort of time-tested statement, know your audience. Or if you do show, you might not want to lead with these types of things. I'm leading with it here somewhat to make a point. So I hosted a workshop along with a colleague, Dr. Kim Cobb at Georgia Tech last January on behalf of the AAAS on climate communication. And one of the things that we noted, scholars have noted, is that scientists, grad students in the art, we're being taught sort of in an inverted way if you're going to speak to the public. In other words, we're taught when we do our theses and dissertations to give a lot of background material, supporting material. You read a dissertation, the first 100 pages is basically lit review, and that's what we do. When we go to a science talk, that's kind of what we do. Or we go to a symposium talk in our departments, that's what we do. So like 40 minutes into the talk, as people are nodding off, they may or may not have gotten the punchline, right? Of course, people don't nod off in seminars in departments, do they? But when we're talking to stakeholders, the public, congressmen, Rotary Club, the public wants the bottom line first and then build backward. But as scientists, as scholars, we are just trained in a different manner. And so that's a real challenge that I see in our field. The other thing is jargon. This is one of the most highly recommended peer-reviewed publications out there on science communication, in my view. It's by Somerville and Hassel, I'm sure that Naomi and others know. When I say bias in science, I know exactly what that means, and it's not a scary, devious term, right? But when the public hears bias, it has a connotation of negativity or devious. I just showed a couple of graphs where there's a positive trend in snowfall. It's increasing. But when the public hears positive, that sounds good, right? It's positive. So these kind of jargony terms that we are just so comfortable with have a danger to them. And so this chart is directly out of that paper in Physics Today, 2011 issue. So I invite you to take a look at that. And then the last part of the second challenge is I have found over the years that when we're speaking to non-experts on this topic, you have to find common ground. I talked to a group of staffers for our congressional delegation in Georgia recently. And Georgia sort of from a political standpoint, ideological, it's probably very similar to Missouri and a lot of other places around the nation in terms of take on some of these things. So what do the staffers, so, you guys keep talking about this drought in California. Why should Georgians, why do our constituents care about that? Then I pulled this up and said, did you go to Subway today for a sandwich? Because if you did, probably something on that sandwich was grown in California. 99% of almonds, 99% of walnuts, broccoli, 95% strawberry. We got strawberries out there on the tray now, right? Maybe California, maybe they're Missouri strawberries, I don't know. Tomatoes, 90%. The point is, that's why our constituents in Georgia care, right? But you got to make those linkages. But then look at what I did. Because I know I'm talking to a policymaker, I flipped the script. I said, but there's opportunity in this for Georgia. Because why is it that California grows 90% of tomatoes? I flipped it, and their ears perked up. I was like, yeah, you're right, why is it? And so they took that back to their company. So you got to know your audience. I know that Missouri is very much a farming state, as is Georgia. We also know that farmers have traditionally been one of the most skeptical groups of stakeholders on climate change. I talked to U.S. Forest Service's Steve McNulty, and he says, well, here's how I address this when I talk to farmers and ranchers and forest management folks that I know may be skeptical. He uses this little approach he calls ELF land. It's an acronym. And what he says is, when we come into groups like this, blazing with our expertise and our graphs, there's a wall that immediately gets built up. Oh, here's this scientist from the University of Georgia and wants to tell me how to grow my peanuts. All right. But what you do is you establish contact and listen. I know, ma'am, that your farm has agricultural productivity and your yields are dependent on how much rain falls here in Albany, Georgia, right? And they agree with that. That's not something that's contentious. And I said, well, are you affected when there's drought? I mean, how do your yields do? So you have a conversation. So you're already sort of breaking down the wall and establishing trust. And when you lessen mistrust, at that point, then you can start to assess needs, nurture, and deliver if there's a sort of deliverable at the end of that interaction of some kind. So and this is basically how I've kind of approached things with certain stakeholders anyhow. But when I saw Steve frame it as this ELF land approach, it just resonated with me because it's kind of how I always approach things anyhow. So I think this is a useful tool when we're particularly going into groups that may sort of skew skeptical on a particular topic. And then one of the largest corporations based in Atlanta is Coca-Cola. Again, establishing common ground when people say, well, how is this affecting me? I mean, people have this perception that climate change is something off in the distance, but you may be paying more for your Minute Maid orange juice or Sprite because Coca-Cola is seeing stresses in things like that essentials they need to make Coca-Cola, Sprite. Coca-Cola owns Minute Maid, things that you're buying every day, right? The third challenge. Hey, Dr. Shepard, I get this tweet. I have 20 inches of global warming in my yard. What are you guys talking about? All right, you get that one when it snows. All right, it's it made me chuckle too, but it's so scientifically wrong because it just illustrates the lack of understanding between weather and climate. And I find this to be a significant problem in the public sphere. People just don't understand the fact that it might snow tonight in Missouri, which I hear there's a slight chance of it doing, that says anything about climate. And so I've somewhat become known for this little saying, weather is your mood and climate is your personality. I mean, you could be in a bad mood today, but it doesn't necessarily say anything about your personality, right? But if I start to take some type of mind-altering drug that then alters my personality, it might start to affect my mood more each day too. So you think of that drug as the anthropogenic climate change on the climate system. Professor Stokes here is a psychologist, so I hope some of this is resonating because I'm sort of violating some of my own rules because I'm foraying a little bit out of my expertise area in the psychology. And I'll actually have some more on psychology later in this talk. If you don't like that, here's the sports in the title. So another way that Deke Arndt at NOAA tries to explain climate to people, LeBron James is weather, former coach David Blatt is climate. He reached the tipping point and has now been fired. It's a little sports here. So he has all of these plays, all of these realizations of what can happen on the court. But what actually happens when the timeout ends is what LeBron does. That's weather. And here's another sports item for you. O.J. Simpson was a great NFL player, but part of our challenge in communicating climate, I blame somewhat on O.J. Simpson in the O.J. Simpson trial. Well, what do you mean by that? For you that are under, age 18 or so, he's a football player. He actually had a big trial involving his wife, was riding down the road in a big white, and I digress. But the point is, we became very aware of the process, the legal process, and the concept of reasonable doubt. And what I have found is that many people in the public, and even some stakeholders, think that science works like a court case. If you can establish some uncertainty, then the science is wrong. Oh, I can't trust those climate models because they're uncertain. But science doesn't work that way. As we were talking about the other day, my colleague, Professor Urban here in geography, people use information with uncertainty all of the time. If I told you there's an 80% chance of rain tomorrow, would you take an umbrella along? Most of you are nodding yes, but that information had uncertainty in it, right? A doctor's diagnosis, your financial advisor on your portfolio, they give you information all of the time that has uncertainty in it, but there's a lot of uncertainty, unusable information there too. So we must remove this notion that uncertainty means we don't know. But that sort of really prevails in a lot of the climate discourse. So this is one that I get all the time as a climate scientist. Well, Dr. Shepard, the climate has always changed. The climate changes naturally. Now, I assure you that if I had made it through Florida State University's bachelor's, master's, and PhD program in meteorology and I didn't know that climate changes naturally, I should give my degree back. So you don't need to tell me that. I understand that the climate changes naturally. I'm always amused when someone tells me that or tweets me that. Of course the climate changes now. Here's an example of it. This is the last 800,000 years or so of CO2 change, right? But then after the industrial evolution, look, we got outside of the natural cycle. There's a steroid on top of the natural cycle. But I see this misused more than anything. Because we are now in a climate system unlike we've seen in the last, we haven't been around burning fossil fuels that long. So there's no analog to compare this current climate state to. So it's important when people, I was just doing an interview with a local public radio station, and she said, well, what can we as people do? I get this question, what can we do about climate change? And you hear the previous speaker talk about the squiggly light bulbs, et cetera. I don't say any of that. I just say if we can help up science and climate literacy, that's half the battle. That's where I focus a lot of my effort. I don't talk about squiggly light bulbs and things. Because people, if they don't understand these types of things, they misuse them. All right, fourth challenge, overcoming perceptions in psychology. Overcoming perceptions in psychology. I don't know if you remember a couple of years ago in Atlanta, we basically shut down because of 2 inches of snow. 2 inches of snow, and it was like the Walking Dead out there. I mean, there were literally cars abandoned and people walking down Interstate 75 and Interstate 85, literally. I am not joking. And this is kind of pivoting the weather a little bit. This was because of a perception issue. The perception was, we had been under a winter storm watch in that region for snow to Metro Atlanta and south. But as time went along, that snow was creeping, and the forecast was moving further and further north. So the Weather Service issued a winter weather advisory. But everyone in Atlanta thought that was a downgrade. They thought going from a winter storm watch to an advisory meant, oh, it's better, we're in the clear. So we didn't make proper preparation. So that as a perception issue, it's probably a communication issue on the part of the meteorology community too, because we haven't done a good job of explaining the differences between watch, warning, and advisory. And so there are actually some social sciences efforts to do that now, which let me get on a soapbox for a second and say, we cannot do physical sciences in a vacuum now. Social sciences and humanities-based research is very critical. The psychology of how we use weather information, communicating of it, that's very important. So I wanted to kind of mention that. Here's another perception issue. How many meteorology students and meteorologists in the audience? I know there are some. So those people that are raising their hands have heard this before. It must be nice to be in a profession where you get paid to be wrong 50% of the time. You've heard that. Who's heard it? Raise your hand. You've heard it, of course. And what I have found is that that statement, again, illustrates a science literacy issue, right, and a perception issue. I was tubing in Helen, Georgia. Who knows where Helen, Georgia is? Some people might know. You can go get these little tubes and tube down the Chattahoochee River. It's a little sort of faux German community tucked away in the North Georgia mountains. And it rained as we were tubing down, and we had to get out of our tubes. And this lady next to me, she didn't know I was a meteorologist. She didn't know who I was at all. She said, see those meteorologists, they don't know what they're talking about. It was a 20% chance of rain today, and it's raining. And in my head, I'm saying, well, it wasn't 0%. But more importantly though, people would, again, I'm not just picking on the public, because my colleague Dr. Knox and students just published a paper in a peer-reviewed journal showing that even meteorologists in the National Weather Service and the TV world don't quite understand it. There are different understandings of what it means, right? If I had I'm a professor, so if I had my chalkboard, I'd break it down for you. But it really is percent of chance is related to the confidence that the forecaster has times the area that he or she thinks is going to get rainfall. So guess what? We were in that 20% forecast area that day. That wasn't a bad forecast at all, right? Now, it's just the best we can do with rainfall we have to do forecasting of rainfall in probability fashion. But guess what? A lot of the public doesn't understand probabilities. So it's a challenge, but it's the best we can do. And here, just as a laundry list, here are lots of other weather myths and things that I hear all of the time. I'm not going to go through all of these. People think heat lightning is a thing. It's not. It's just a storm too far away to hear the thunder. It's not caused by the heat of the day. People think it can't get cold in deserts. Every time it gets cold, people think the polar vortex is swooping down to get us. Polar vortex is actually a large dynamic feature that's always in place. So these are the types of things. Another little soapbox item, let me get on for a second. I know you have an app on your phone. I do. Be careful with your weather apps. They're particularly in evolving, rapidly developing weather situations. They're not going to help you very much. And in some cases, the algorithms that are associated with these weather apps are very late, sort of they're not updating. So be a little careful with that as well. On the climate side, in terms of perception, and Naomi actually, there was a feature on, not Inconvenient Truth, what's the movie? Merchants of Doubt. Bob Inglis is a part of Merchants of Doubt. He was actually at the University of Georgia last year, and he will be on an upcoming episode of Weather Geek soon, too. There's a perception that climate change is a left-right issue. I'm a good conservative, so I can't believe in climate change. Or vice versa, I'm a liberal, so I have to. It's none of those. It's not a left-right issue, it's a human issue. Admiral Dave Titley, Penn State, former oceanographer of the Navy, says, the climate doesn't care if you're a Republican or a Democrat, the ice just melts. Right. So this is Henry Paulson, President George W. Bush's secretary. Look what he says. I'm on the board for the Nature Conservancy in Georgia, and he's a big supporter of the Georgia Nature Conservancy. He said climate change is a challenge of our time. Look, he'd have an R behind his name if I put it up there. Bob Inglis, one of the most conservative congressmen in Congress over the last 10 years. Republican. Lindsey Graham, I've come to conclude that greenhouse gas and carbon pollution is not a good thing. I'm going to let you guys marinate on that one. But hey, it's progress. it is not a, I often say if, Al Gore and John McCain had just done Inconvenient Truth together, we might be in a different place right now. Because John McCain was very much where Al Gore was to some degree. But that's sort of water under the bridge. Okay, from a psychology standpoint, there's some interesting work by Robert Gifford, a psychologist at University of Victoria, and it was featured in a recent article by Beth Gardner in the New York Times. And he talks about the fact that people there are 4 things that are struggles in communicating climate. People have trouble imagining a future just drastically different from what they're used to. I mean, they struggle with that, so they kind of put it out of sight, out of mind. We block out complex problems that lack simple solutions. And in a paper that I published a couple of years ago, a lot of these solutions aren't on 2, 4, and 6-year time frames either, right? Which is a problem in itself in terms of getting policy action. We dislike delayed benefits and so are reluctant to sacrifice today for future gains. Well, although I get what he's saying here, I'm trying to sort of change that narrative because a lot of things are happening now. We don't even have to talk about delayed things anymore. There are things happening now, right? Ask Canadian doctors who now have to figure out how to treat Lyme disease. They didn't even have to worry about Lyme disease decades ago. George Luber perhaps has some thought on that because he'll be talking a bit later today. George Luber actually is a good colleague that's here as well. I make sure you catch his talk and Naomi's very good talks coming up from CDC. And we find it harder to confront problems that creep on us, but we react to emergencies. There's some literature out there that suggests that someone that may be skeptical on climate change, if their house floods, right, and they have to claim flood insurance, they sort of change their view. So some of this is actually just, it's a really interesting psychology behind sort of climate change framing. The 5th challenge, the causation problem. What do I mean by this? Well, every time we have a big weather event, Dr. Shepard, was that caused by climate change? The media, is that caused by climate change? Well, I just served on National Academy study that just released what we feel is the benchmark report on that question, right? And again, here's another sports angle. This is something I wrote in Forbes very recently. I say when a team plays basketball, there's natural variability in the outcome of each game. We're in March Madness right now. We're seeing that variability now if you're following your brackets and you're like mine are shot. There's natural variability in the outcome of each game, but as teams practice and attain better players, there's a bit more signal on the potential outcome of the game. So as a team becomes better, they get better players, even though there's still variability in the outcome of that game, a better team is more likely to win more of those games. So that's how I think about the sort of juxtaposition of natural variability and anthropogenic climate change. So in that report, one of the kind of key findings from this National Academy report is we now have a cascading range of confidence in our ability to link certain extreme events to climate change. And events that are related to extreme heat waves, and the lack of extreme cold events, we're seeing less occurrence of these, we have high confidence. We have moderate confidence in extreme rainfall and drought linkages to, and then tornadic storms, we don't have as much confidence. The science is not there yet. Now, just because some of these have low confidence right now doesn't mean they're not necessarily ultimately linked. It's just the science is not there to say that conclusively yet. Our goal, our task from our sponsors for that report was to assess where we are in the science, right? So when we look at these different events, we were able to attribute our confidence based on the capability of the climate models to simulate these, the quality and length of the data record associated with these, and our basic physical understanding of those processes. And so that's why we come up with high for these events, and this is lack of cold events. So I encourage you, if you're interested in this, there's a 144-page report out there on the National Academy of Sciences website. And then the final challenge are zombie theories, what I call zombie theories. Zombies are really big now in culture. I don't know why, I don't get it, but they're really big. Yeah, exactly. They never go away. They filmed The Walking Dead, which many of you may watch, in the state of Georgia, so we get our share of it. And that's the point. Naomi says they never go away. And there are these theories that are out there in social media and in blogs, op-eds, that the science has long slayed or killed off, but they just live on like zombies. So I call them zombie theories. It's the sun, Dr. Shepard. You want grant money. The models are unreliable. There's a website that I would point you to that really deals with all of these, if you ever encounter any of these. I mean, because trust me, there's essentially nothing that can be said now that I haven't heard, really. And there's, we generally understand these things very well. So these are what I call zombie theories. Now, this is actually, I tried to get a picture of University of Georgia Sanford Stadium, and I think we were playing Missouri that day. I think. And I think that's the Missouri section over there. Well, it makes sense. No, it's in Athens. I'm not taking a shot at Missouri. But my point here is, as I kind of draw to a close, if a CNN reporter comes and takes one person from that section and one person from this section and puts them on the air and says, look, there are equal number of people in Sanford Stadium that day. Is that the case? No. But that's what we see when we stage these sort of arguments on CNN or Face the Nation or the Weather Channel or others, sort of one-to-one, because the science is not balanced. And I had some conversations with your very excellent journalism school while I was here on that whole notion of false equivalency, because journalists are trained that way, right? So I just wanted to say that in closing. So as I go to my seat, this is often one of my favorite little cartoons, because this kind of comes full circle to what I started this talk with. This poor physicist or whatever he is saying all of this, but then some guy saying, no, some guy on Twitter says you're wrong. Right. So hopefully those 6 challenges resonated with some of you, and some of my comments resonated with you as well in terms of how we can address and solve some of those as well. Thank you so much for your attention. So,
we have time for a few questions, so raise your hand if you're interested. We'll bring you a microphone.
happy to try to answer. I'm very comfortable saying I don't know if I don't know that.
Great talk. Enjoyed it very much. I am interested in the juxtaposition of your psychology and zombie theories.
Yes.
Because there's a fair amount of evidence that the best way to reinforce a zombie theory is to provide evidence that it is a zombie theory.
Right.
And I don't know if you have any great insights about how to deal with this, but many of us deal with it on a regular basis, and we're grateful for any help we can get.
Well, I mean, I would certainly recommend places like the Skeptical Science, realclimate.org, and other websites out there that are trying to address this. I think one of the things that I increasingly don't do is, when you engage and give credibility to a zombie theory, so when you sort of acknowledge it, you give it credibility. So in a lot of things that I deal with these days, particularly in the social media framework, I just have to ignore it. Because when, Dr. Shepard is actually going back and forth with someone on Twitter on a topic, when it's it was not credible from the start, I give it credibility immediately. So I wish there was more that I can say, and perhaps Naomi will say a little bit more about this today in her talk as well, because I know she deals with some of these very issues, perhaps even more than I do in some cases. So.
Hi, what is that show? Looks like a news show that you were showing that you are on or were on. And
Weather Geeks? It's called Weather Geeks, yes. That's far back, but it's a show on the Weather Channel. It airs every Sunday at 11 Central, 12 Eastern. It's just a Face the Nation format type show, except it's probably the only show in the nation on a national network that talks science every Sunday, whereas everyone else is talking about elections and all kind of other stuff. We're just flip over to us. We're just talking about science.
You're on that regularly?
I'm the host.
You're the host? Great.
Yeah. Yes, ma'am. I guess one of the, before Melissa Harris Perry kind of melted down on MSNBC, she and I were the only two sort of tenured professors sort of hosting a show, but I guess I'm down to the only one right now, so.
Yeah, I appreciated your use of metaphor during this talk. It's, of course, very effective.
Thank you.
The basketball one is particularly interesting.
Thank you.
But I would say that Yesterday's NCAA results suggest that it may not be as useful to you as
Yeah, that was the point I was trying to make when I said my brackets were tanked.
yeah, but because the trends were not fulfilled.
Well, I think that also illustrates my weather and climate comment too, though, because that's sort of, even though Middle Tennessee State beat Michigan State, the likelihood is if Michigan State and Middle Tennessee State play each other 10 times, I'd probably suspect Michigan State would win a large percentage of that. So.
Could you talk more about the cultural importance of meteorologists in their communities and maybe their role as potential sort of drivers of change?
You mean TV meteorologists specifically?
Yeah, the TV.
Okay. Yeah, because as former president of the AMS, one of the things that we've dealt with a little bit is sort of the notion of meteorologists and who and what they are, because we have 15,000 members of our society, 14,000 and some change, but only 7% are actually TV meteorologists. So most meteorologists aren't on TV, even though when I tell people I'm a meteorologist, I get 3 questions right off the bat. What's the weather going to be tomorrow? What channel am I on, or do I believe in climate change? Those are sort of the 3. But one of the interesting things is there are studies, there's a good percentage of television meteorologists that have sort of skewed skeptical on climate. Why that the American Meteorological Society and other organizations are addressing that is that the television meteorologist for most of the American public is the only quote-unquote scientist a public member is going to experience in their lives on a day-to-day basis. Think about that. Go to Walmart or Target and ask a person what scientists have they come in contact with today. Probably, and well, in a community like this, perhaps they did run into the physicist there in the cereal aisle, but in general, most of the public is not going to come in contact with a scientist, so they see the meteorologist on television. And there have been some studies, Ed Maybach up at George Mason University and the groups at Yale and Yale Climate Communication have kind of looked at some of this for the AMS. We commissioned one study actually while I was president of it. We wanted to understand what's going on there. And there's some of it there's small percentage just ideological. Some of it is the fact that I'm a card-carrying meteorologist. I have 3 degrees in meteorology, but I also teach in a program that is heavily climate-focused within a context of a geography program. Meteorology curricula and climate curricula are not the same. In a meteorology degree program, which I've been through one of the top programs in the nation, you get 1 climate course. And it's a very survey course. You don't get courses in climate models or paleoclimate records or time series analysis or physical climatology or energy balance. Those are essentials to foray into this discussion. So, I've actually had colleagues say, well, how can I trust a weather model when I know I can't trust it, a climate model 80 years out, when I have heard that I can't trust a weather model 7 to 10 days out? But that question illustrates a fundamental lack of understanding of the differences in the models. It's an apples and oranges discussion. But when someone that you might think perhaps should have known the answer to that doesn't, it illustrates that there's a gap. So that's one thing they found. Secondly, there's just a fear of talking about it in their media market. Ratings drive television, all right? But all hope is not lost, because there are good examples like Greg Fishel in North Carolina and Jim Gandy in South Carolina, very conservative markets, but they very much talk about climate change. They present it in a very sort of consumable way. So that's not an excuse either. And then in some of those surveys just said that they don't know enough to feel comfortable talking about it. And I commend that answer on that survey. So that is a challenge we're facing. I'm seeing, just looking at the data that I've seen recently, there's some movement on that, as you're starting to see certain perspectives out there, and even at things like the AMS Broadcast Conference, you're starting to see climate workshops, climate literacy workshops from experts, et cetera. So.
All right, so I'll start off by saying I used to be pretty skeptical about the whole climate change thing. I'm more in the biology department, so I think where a bit of this skepticism is coming from, even within the scientific community on climate change, is correlation versus causation. So could you touch up on, like, at what point could we start saying, like, okay, even though we don't, like, if we do have causative data that's showing that CO2 levels increasing our climate as a result, at what point can you say, I think that will clear up a bit of the kind of confusion, if you will?
My answer to that is I think it's already cleared up.
All right.
I think there are still people that doubt it, but I can't fight that battle. I think that let's see. I mean, if I had plotted a temperature chart on, I mean, yeah, the correlation causation, but if I had plotted a temperature chart on this, I mean, look, clearly the temperature does what the carbon dioxide does. Well, you can say that's correlation causation argument, but you know, Arrhenius back in another century and others talked about the basic physics relationship driving CO2 and temperature. I mean, there's basic physics that explains this, that is 100 plus years old. I mean, 100 plus years old. I mean, basic physics, right? There is basic physics that says when I go up the top of this building and jump off, I'm going to the ground. Right? But you can be skeptical of the theory of gravity if you want to. So I think that's an issue. Now, the causation issue as it relates to stream events, that is what this report that we just released talked about. Because that's an area where we have been a little bit iffy. It drives me crazy when I hear someone say, oh yeah, Superstorm Sandy, that was caused by climate change. You know what? I can't say that. I just can't say that. No more than I can say a Major League Baseball's 300 players' 320th home run was caused by steroid use. I can't, he probably could hit home runs anyhow. So I can't say his 320th home run was caused by steroid use. But I can look at his overall statistics and see an imprint of steroids in the length and record and number of his home runs hit. And so, I know there are 30,000 scientists out there that say that climate change is a hoax. There's this sort of secret society that they're all getting. I never got my membership card, by the way. But whatever your field is, you said it's biology. Yeah. I trust your expertise if you tell me something about like mitochondria or something. I don't know, is that a biology term? I trust your expertise more than mine on that, right? So.
All right, thank you.
My question follows on that, actually. Great. I was actually worried this was too geeky, but now I think it's perfect. So it's about causation, and it's about the extreme weather thing, and about exactly something you just said about what I can and can't say.
Right.
Because I want to argue that what we think we can and can't say as scientists is both an epistemological question, but also a cultural one.
Exactly.
So, and I have not had a chance to read the new Academy report, but I have downloaded it.
Good. It's a long read.
It's going to be my plane reading coming back here, but I was too jet lagged from coming back from there. But I will read it so we can continue this conversation.
Absolutely.
But here's the question. So, like you just said, the steroid example is a good one, right? We can't say that any one home run was caused by steroids, but we can certainly notice discrepancies between what kinds of home runs people were hitting before and after steroids. And so we can certainly say that the steroids are a contributory cause, or they're part of the cause, or they're part of the explanation.
Exactly.
So, I want to give another example, which is the example of cancer and smoking. So it's very analogous to what you just said here. There's always been cancer. Cancer is a natural thing, just like climate variability is a natural thing. But lung cancer rates spiked dramatically in the 20th century.
Sure.
And what is the thing that we say caused that spike? We would say it was caused by the increase in smoking.
The spike was caused.
The spike was caused by smoking. And we use the word cause, and we don't hesitate to use that word cause, even though it's true, just like the home runs and just like Superstorm Sandy, that no one case of cancer can be absolutely positively attributed. Yet we still say that smoking causes cancer.
Yes.
And we still say that smoking caused that spike.
Right.
So I guess I want to push you a little bit in a friendly, supportive way.
I know. We heard it in our committee. We even had people on our committee that was kind of coming from the angle you were.
That's kind of my question. Like, I feel like scientists are being a little bit, I don't know what the right word is, but...
Conservative?
Yes, definitely conservative, and a bit almost precious in a way, like, oh no, I can't say that.
Exactly.
But epidemiologists say it, so I want you to just invite you to explore that.
Thank you for that question. It's a great question, actually. So, one of the things that we kind of argue in the report is that moving people away from saying Sandy or Katrina was caused by climate change, or the Russian heat wave of 2010 was caused. We actually invite people to sort of frame it as, are these events becoming more frequent? Are they becoming more intense because of climate change, which kind of represents that spike? So I guess the framing of the smoking analogy used is that smoking didn't cause cancer necessarily, but it caused the spike that we saw over time. And I think we're sort of talking about the spike too. But one of the things that I would say is I think historically the no matter what you see out there in sort of social media and all these things, climate scientists have been probably overly conservative because a lot of the, so for example, take Arctic sea ice in the northern hemisphere. If you look at the climate model estimates of decline of sea ice, for example, and there are many other examples I could choose, the climate models are projecting a decline and perhaps even an ice-free Arctic, maybe 2050, 2100. The point is, the trends in decline in Arctic sea ice in the warm season are well ahead of those projections. So in other words, the nature of scientists to be conservative on some of these things are driving a bit of conservative. So a lot of the things that we're seeing happen are happening well in advance of some of our best conservative estimates. Now, immediately I'll have someone out there saying, well, you got growing ice out there in the Antarctic. Well, again, that's just a misunderstanding of how our climate system works. But the Antarctic region is very different from the Arctic region in terms of the dynamics of the atmosphere. And it's very much increasing snow mass on the center of Antarctica, declining sea ice in the Arctic is very consistent with what we might expect in a warming climate system. But it's counterintuitive to people, right? So I would agree that to some degree on that, Naomi. And one of the things we talk quite a bit about in this report is this concept of what we call fractionable attributable risk, or FAR, which you may be familiar with. And so there are studies now that are actually trying to put a fraction of attribution to climate change on a particular event. There are actually research groups around the world doing something called rapid attribution. As soon as an event happens, they go into sort of a modeling mode and can try to come up with some degree of risk attribution to that event in almost quasi-real time. So I think we're there. I actually probably won't challenge or sort of push back much because I would agree that we probably are, but one of the things we think is so important about this particular Academy's report is we think it did shift things from a bit more of a hedging. We really don't just say, well, we expect those kind of events. We really say that we have pretty high confidence that certain heat waves that have happened recently have an anthropogenic climate change signal in it. We say that very confidently in that report, and that's something different from previous efforts. So.
I'm from the medical field and very, very familiar with clinical trials.
Sure.
And I'm also aware that there's sometimes you really don't want to do one. There has never been a clinical trial that proves that antibiotics cure bacterial meningitis.
Right.
It will, you really don't want to do that trial.
Right.
And it seems like we don't have any data to support it from a clinical trial standpoint, but you wouldn't want to do this. And the data seems to be pointing in a high-risk situation here as well.
Yeah, absolutely. Yeah, your point about some of the medical field in some ways deals with some of the same types of issues and challenges we face in this discussion. All right.
Just a point. Naomi's point about cancer. We have mechanisms by which cancer happens, and as someone who's taught science to non-science students, when we talked about global warming, we put a Coke bottle and put some water vapor and some CO2 in it and stuck it out in the sun and measured the temperature and explained about infrared radiation and so forth. And it actually, that connected the phenomena. And so the question I have for you and also for Naomi is how do you get non-scientists to think that mechanism stuff? Because so much of what's covered is phenomenology.
Yeah, that's a great question, and I'll take it up. So the question basically is sort of this phenomena enforcing mechanism on the climate system and how we can get the public to understand that. So here, this is one of the biggest challenges, and I probably should make it a 7th challenge actually, because people have this understanding that the sun, that greenhouse gases, that land use change, and a few other things are things that drive our climate system's forcing, right? I think generally people have that understanding. But what I see a lot of is that people think that they're sort of equally a part of what's driving our energy balance. When, if you look at and again, this is a problem where most of the public's not going to read the IPCC report, but there was a really nice article, I forget where it was, Bloomberg or someone that did an article showing the relative contributions of greenhouse gases versus the solar forcing versus aerosols versus a line of things. And the greenhouse gas forcing is orders of magnitude more than some of these other forcing functions that people say, well, no, that's what's causing, right? I mean, it's orders of magnitude. It's like saying, someone going to a bar here in Columbia or Athens, and God forbid they drink a liter of rum or whatever, and they're driving intoxicated, right? But they also ate a cupcake, right? You say, well, the cupcake may have caused the accident. Right? So that's sort of how some of the arguments that we see in terms of the relative influence of the forcing in the system, right? Naomi,
Yeah, I would say, I think you're right. I think this also speaks to the earlier question about correlation and causation. So scientists do have a very strong mechanistic understanding of many aspects of the climate system, based, as Marshall said, in basic physics and chemistry, which is how Arrhenius and Guy Callender were able to predict this a long time ago, and I'll talk about this more in my talk this afternoon.
Good.
So we do have a mechanistic understanding, but I think, Marshall's right that scientists haven't really explained that. There's been a tremendous focus in the scientific community on the data and the phenomenology, and we could talk more about why that's been. I think there are some historical reasons for that. We could get into later. So I do think that's a problem, and I do think maybe that would be a point A, is that actually scientists could do more to explain the basic physical understanding that enabled scientists to predict this. And in my own talks, I do that, and I make the point that this is not just a correlation. This is actually a prediction that has come true. And I find that when you explain that to many people, for many people that does help. The other thing I would say is if we think, again, about the tobacco case, it is true that today, with advances in genetics, we can explain in mechanistic ways why, Aunt Sally smoked 2 packs a day for 30 years and didn't get cancer, but Uncle George did. Right. But that's a relatively recent thing. The epidemiological and biomedical acceptance of smoking as a cause of cancer actually predated that mechanistic understanding, and so did many of the civil lawsuits in which individuals who suffered or their families actually did receive settlements from the tobacco industry in which juries held that the statistical probabilistic evidence was sufficient to say, yes, this was a contributory cause to that person's cancer. And the other analogy that I think about is one of the things the tobacco industry tried to argue in many of the tobacco cases was that a typical smoker didn't necessarily only just smoke one brand across the course of his lifetime. And so, Philip Morris tried to say, oh, well, they smoked Camels, and therefore this is an R.J. Reynolds problem, right? And courts consistently rejected those kinds of arguments. So if you smoked 5 different brands across the course of your life, the fact that you smoked 4 other brands did not get Philip Morris off the hook. And again, it's this notion of contributory causation, and there's actually a term for it in legal term, which is the collective and several responsibility. So yes, there can be other causes, and we don't deny that the sun plays a role in climate. We don't deny that aerosols play a role in climate, but that doesn't obviate the responsibility of greenhouse gases.
Exactly, yeah, and I think that's the key. And I agree. I think that's a point that many of us can do better. I don't know, maybe 1 or 2 more questions? Okay.
Okay, so I'm a biology major. I'm not a meteorologist, so this question may be, I don't know.
There's no dumb questions?
So I was under the impression that we are trying to move away from the term global warming, and we're moving towards the term climate change in place of that. However, I've also taken a lot of science classes, which my professors always try to discuss climate change and global warming due to the fact that pretty much all science relates back to that. And they've oftentimes defined global warming as a different phenomena than climate change. So should we be even be using the term global warming anymore, or moving away from that?
The question is about the term global warming versus climate change. Honestly, that's just all smoke and mirrors for me. I think that kind of argument has been misused and sort of strategically used to confuse people. It doesn't matter to me. But the point is, and I'll kind of clarify it somewhat, climate change, I've heard things like, oh, they changed the name because they don't have any evidence it's happening, or those kind of things, right? So the reason climate change for me is a term that I often default to is because I just look at global warming as one aspect of climate change. So if my daughter has a fever, right, she has other symptoms too. So I'm not describing the fact that she has the flu by saying she just has a fever. And so I think global warming is just, climate change is also the change in the increase in frequency and intensity of hurricanes, right? That's climate too. So again, it goes back to this whole misunderstanding of weather versus climate, because weather events, climate events are somewhat different things. So warming is just one facet of the climate system. It's not the only thing. It's not just getting warmer. Other things are happening too. Sea ice is declining. Those are climate changes. Right? So that's climate change is just a more appropriate term in my view. So that's, and by the way, I have a student that's published on that. If you're interested, Dr. Teresa Anderson, who published some work on that. If you want more reading on that, but a lot of that is just smoke and mirrors, right?
As one of the few social sciences.
Oh, okay. I hear you, but I don't see.
Sorry, I'm here.
Oh, there you are.
One of the few social scientists here in the School of Natural Resources. I really appreciated that you highlighted the importance of social and behavioral sciences in this area.
Yes.
So I'm wondering if you could say just a bit more about how we can contribute, how we can and should contribute to.
Yeah, not only can, should, and
Yeah.
should actively
Yeah,
be
what do you
considering.
need
And I
from
would
us?
challenge funding agencies to, as we're seeing attacks on social and behavioral sciences at National Science Foundation and others by policymakers, that's just ridiculous. Because I'll give you an example. Our weather models and weather forecasting, technologically wise, are actually pretty good now. So we know when a tornadic situation is going to affect Moore, Oklahoma, or El Reno, or Joplin, Missouri. All right, Joplin being relevant to this state. That wasn't a surprise that there were going to be significant tornadoes on any of those cases I just mentioned, yet people still died. And what we're finding is that the technology is there on the weather side, but people still consume the information. The whole thing I was talking about with watch versus warning, people sort of still have their own sort of psychologies behind why they make certain decisions. So Alan Stewart is a professor at the University of Georgia, educational psychologist. He found, I gave this example at dinner last night, he did studies along the coast, and he found that when people are explained what the hurricane scale means, they had category 1 through 5, they think a category 2 is only a little bit worse than a category 1. But when you explain it has really more of a logarithmic measure in sort of the same way that the Richter scale does with earthquakes, their behavior patterns change in terms of whether they evacuate it from the next storm. Right? Communicating risk. One of the things the Weather Service is doing right now is they're evaluating the color schemes that are being used. Right now, if there was a tornadic storm situation bearing down on Columbia, Missouri, you flipped on each of your favorite television stations. Each of those TV stations may be using a different color scheme to warn various hazards. Is that a good thing or a bad thing? Studies have shown that certain colors evoke action more than others. Those are social and behavioral science related questions, and there are a host of others. So, and in climate science, I think they're relevant as well. So.
Thanks very
Thank
much.
you. Yes. Thank you.